Hello and welcome to Lesson 9.6, Dilations. This is not a typo. This is where you're supposed to be. We are just pulling in this lesson from Chapter 9 because it specifically talks about dilations. And so we're going to focus on this lesson from Chapter 9, then we'll be back to finish out Chapter 7 with the next lesson. All right. So in the past, we've identified dilations and we verified them as similarity transformations. Well, now we're going to still identify and verify dilations, but we're also going to work on drawing our own dilations. And that's going to be the key difference in this lesson from Lesson 7.6. All right, so here's our key concept for a dilation. A dilation with a center C and a positive scale factor, we don't have negative scale factors, is a function that maps a point P in a figure to its image such that if any point P is at the center, basically if the center of dilation is a coordinate, then that point doesn't change, it stays the same. But if C is not the center of, or if the other point is not the center of dilation, if P is outside the center of dilation, then P prime, which is the result after the dilation, lies on ray CP, or we could call that a vector CP, and C prime is equal to the scale factor times CP, meaning this length, CP is 4, CP prime is the scale factor times 2.5, and we're using a scale factor of 2.5 here. So 4 times 2.5 is 10. We could do the same type of measurement to get from CM to CM prime and CL to CL prime. And notice we're using this prime notation for the image after the dilation. In your book, you're going to notice that the original figure is in blue and the dilation image is in green. So let's practice that on our own. Now, my measurements, if I were to line these up with a ruler, they're not going to be the exact same that you would have on your notes. In fact, if you look at the notes page, I've got one here. If you take these measurements, they're going to be the measurements that I give you here in just a second. But you will need a ruler to do this problem, so hopefully you have a ruler. Hopefully you can find one, or you should have the one that was given to you. The first thing we want to do is to use that straight edge and to make rays that go through each vertex of our, in this case, trapezoid. We're just going to extend them quite a ways out. And so these are the rays that we're going to extend our coordinates out to get Q prime, P prime, S prime, and R prime. And then it says to use a scale factor of 3. So we're going to measure these distances and multiply by that scale factor of 3 to get our other distances. Okay, so when you measure, CQ should be about 1.5 centimeters. CP is 2.2 centimeters, and CS is 2.2 centimeters, and then CR is again 1.5 centimeters. And so I'm going to take CQ and CR and multiply those by a scale factor of 3. Okay, and those are both the same measurement. It's going to be 3 times 1.5. We do 3 times 1.5, we get 4.5 centimeters. And so Q prime and R prime are going to be along their respective rays, but we're going to measure out 4.5 centimeters. So there's 4.5. This will be Q prime. We're going to go along CR. We're going to measure 4.5. And that will be R prime. Then we're going to do the same things to get P prime and S prime. Remember, CP is 2.2, so we're going to do 3 times CP, or the same for CS, and get 3 times 2.2, which is 6.6 centimeters. So we're going to measure out along C prime 6.6 centimeters. And there's P prime. I'm going to measure along CS, 6.6 centimeters. And there's S prime. And now all we have to do are connect the vertices of this new trapezoid. If you've done it right, we should have parallel segments for and then the two legs of the trapezoid. Now you'll notice it might look a little bit off, but for the most part, this is what it should look like. All right. So what I want you to do is take this next part, and I want you. We can actually just use our checking methods here. I want you to tell me which of these diagrams shows the dilation of triangle LMN, which would be triangle L prime M prime N prime, where the center is C and the scale factor is 1/3. Okay, so which of these shows triangle L prime M prime N prime 1/3 of the way between C and its original triangle LMN? Okay, use your ruler and check those distances and see which one is 1/3, and then we'll check our answer. If you need more time, pause the video. Alright, if you need any more time, pause the video, but this is what we should get. Okay, if we take these measurements, when you measure your figures, we should get LC is 3.3 and L prime C is 2.2 for A. Now, that would make that a 2:3 ratio, not 1:3. But if you take measurements for B, we get LC is about 1.1. You might have said a little bit more than that, but it's pretty close to 1.1. And I'm sorry, that's L prime C prime, and LC is 3.3. That means that that ratio is 1:3. 1.1 over 3.3 is our 1:3 ratio we were looking for. So our answer should be B. If you looked at C, that's about 0.8 to 3.3, not what we want. And D isn't how we would do a dilation at all. Okay, the image from a dilation should be along the same ray as your pre-image, and in this case we extend beyond the center of dilation in the other direction, and that won't work. All right, let's take a look at example 2. All right, in this example, we're talking about a version of puppetry that uses the illusion of a life-size image. They sometimes place a light source to show an enlarged image of a puppet projected on a screen or wall. Suppose the distance between light source L and the puppet, so LP, is 24 inches, and they want to know to what distance should P prime place the puppet away from the wall to create a 49.5 inch tall shadow, or I prime M prime, they're going to call 49.5 inches, if the puppet is 9 inches. And so here's how we're going to do this. We're going to identify the scale factor by comparing I prime M prime to IM. Okay, so that scale factor would be 49.5 to 9, and that should equal about 5.5, actually exactly 5.5. So we're going to use that scale factor to find our ratio LP prime. And so since we're using this ratio, I'm going to go ahead and make that over 1 just to make my number smaller. That's going to be LP prime over LP, which I know is 24. And so all we have to do to solve this is to cross multiply, and 1 times LP prime means I take 24 and I multiply it by 5.5, which means LP prime is 132. Because really you're just saying that the distance from the light source to the wall is 5.5 times the distance from the light source to the mannequin or to the puppet. And so if this entire distance is 132, I simply need to take 132 minus 24, and we get that the distance from the puppet to the wall should be 108 inches. Alright, let's take a look at the next part of this. For these next couple examples, we just need to determine whether it's a reduction or an enlargement, and then find the scale factor, and then we're also going to find the missing value to help us with that. So we're going to determine whether the dilation from k to k prime is an enlargement or reduction, and then find the scale factor of that dilation and the value of the variable. And in both cases, the value of the variable is going to help us to actually find that scale factor. So here they tell you we take our figure k, which is a pentagon, and then we get k prime, which is bigger than k. It's now 15 units out from the center of dilation F. So this is an enlargement. And the scale factor we represent with lowercase k. If f k prime is 15 and f k is just x, they tell you the distance between k and k prime is 10. That means that x has to be 5. Okay, so that part actually comes first, x equals 5. And then our scale factor compares my image length, 15, to my original length. So our scale factor is 3. 3.0, 3 over 1, whatever you want to call it, but that's what we have. On part B, once again, we have square k and then a bigger square k prime, so this is also an enlargement. Okay, k is the preimage, and then the image after the dilation is k prime. And we have a distance from center of dilation to this vertex of 2, center of dilation to this vertex, which is 1 more than that. That means x is the total 2 plus 1, or 3. So our scale factor, lowercase k, measures that distance, 3, over the distance from center of dilation to the preimage corresponding point, 2. So 3/2, we could say 1.5. Alright, let's go on to our final portion of the notes, which is where we are going to be using dilations in the coordinate plane. And here's what we have. To find the coordinates of an image after dilation centered at the origin, multiply the x and y coordinates of each point on the preimage by the scale factor. So all you're doing are taking the coordinates and multiplying the x's and y's by whatever scale factor you're using. So if we have this segment that we're going to dilate into this segment, we take 2/3 and we multiply each by a factor of 2, we get 4/6. So in order to do this, the graph is going to be helpful, but we can actually do most of our calculations without doing the graph. So we have E, F, G, and H, and so when we plot those points, this is what you should get. Trapezoid, E, F, G, H. And then we're going to graph the image of that after we use a scale factor of 1/4. And so if we have these coordinates for E, F, G, and H, E prime, G prime, F prime, and H prime are simply found by taking 1/4 of each of these coordinates. So we're going to divide each of these by 4 or multiply each of these by 1/4. Either way, these are what we should get. When you take 1/4 of all of these coordinates for x's and y's, we get the coordinates E, -2, 1. F would actually come next, -1, 2. Then G, 2, 1. And H, -1, -2. And we plot those points, we will get the dilation E prime, G prime, F prime, H prime. And it should look like this. And you'll notice that E prime, F prime, G prime, H prime is similar to E, F, G, H. Okay? So now I want you guys to try and take triangle ABC with these coordinates, plot them on the graph, then find your new coordinates after a scale factor of 2 for your dilation, plot those, and check your graph. When you are finished, continue by pushing play and check your answer. Alright, this is what we should get. A prime should be at -2, 2. B prime should be at 4, -4. C prime should be at -2, -4. And we get A prime, B prime, C prime, which is similar to ABC.